Hello everyone, I'm Nadira Uzal, roll number 205012, and the topic of my presentation is graph theory. A graph G is mathematical structure consisting of two sets V and E, where V is a non-empty set of vertices and E is an empty set of edges. As we can see in the example, here V1, V2, V3, V4, V5 are the vertices, and E1, E2, E3, E4, E5, E6 are the edges. Trivial graph consisting only one vertex and no edge. As you can see in the example, this graph contains one vertex but it has no edges, so it will be a trivial graph. Null graph, a graph consisting n vertices but no edges, so it will be a null graph. Directed graph, a graph consisting direction of edges. As we can see, E1, E4, E5, E3, E2 all are pointing towards a direction, so it will be a directed graph. Indirected graph, a graph which is not directed. Self loop in a graph, if edge having same vertex as both its end vertices, as we can see in the vertex V3, so it will be a self loop in a graph. Proper edge, an edge which has no self loop. Multi edge, a collection of two or more edges having identically endpoint is known as a multi edge. As we can see in the example, here V1 and V2 are the two vertices and E1, E2, E3 are its edges. So here E1, E2, E3 will be known as multi edge. Simple graph, a graph which doesn't contain any self loop or multi edge is known as a simple graph. As we can see in the example, this graph doesn't have any self loop or a multi edge, so it will be a simple graph. Multi graph, a graph which doesn't contain any self loop but contains multi edge. So in the example you can see this graph doesn't have any self loop but it has a multi edge, because V3 and V4 is a vertex, but E4, E5 are the two edges of the same V3 and V4, so it will be a multi-graph. Pseudograph, graph containing both self loop and multi-edge. So here in V2 there is a self loop, and in V4 and V3 there is a multi-edge, so it will be a pseudograph. Incidence and adjacency, if we consider EK be an edge joining two vertices V1 and V2, then EK is said to be incident of V1 and V2. So the two vertices are said to be adjacent if there exists an edge joining these vertices. As you can see in the example, here V1, V2, V3 are the vertices, and E1, E2, E3 are the edges which are joining these vertices. So E1 is incident of V1 and V2, and V1 and V2 are adjacent, but V3 and V1 are not adjacent. Now degree of vertex, a degree of vertex V in a graph G written as dV is equal to number of edges which are incident on V with self loop counted twice. If we see in the example, here degree of V1 will be 2, because the number of edges which are incident on V will be 1 and 2, so degree of V1 will be 2. Here in V2 there is a self loop also, so that's why degree of V2 will be equal to 4, degree of V3 will be equal to 2, and so on. Now isolated vertex and pendant vertex, a vertex having 0 as a degree is called isolated vertex, and vertex having degree 1 is called a pendant vertex, as we discussed earlier. Finite and infinite graph, a graph with a finite number of vertices as well as edge is called a finite graph. As you can see in the example, this is an example of a finite graph, and otherwise the graph is known as an infinite graph. Thank you for listening.